So in this lesson, we're going to be talking about something called finite element analysis, or FEA. And the takeaway here is that you're going to be using Fusion to create, let me clarify, you'll be using Fusion to run an analysis on, or simulation on, a part you design, and you're going to load it with force, and you're going to see internal stress. And it's going to give you data to say, hey, this area of the part right in here, it's going to show it to you in colors, is where the highest stress is. Over here is where the lowest stress is. Now usually this is shown with color differentials between blue and red. Red being bad, blue being good. Or you can almost think of it this way, blue being unused material, or material that's not being stressed, and red being where it is being high stress. And the way technically finite element analysis works is it looks at, it is a little bit more complicated in terms of the math. It does a lot of matrix algebra to figure it out, but it's the concept that if I have all of these parts and I start moving, if I put stress on something, this one little section right here is going to have to move. Well, it's going to pull all the others along with it. And through that, one has to move and another one has to attach to it and move with it, we get the ability to run this type of analysis. Now FEA is actually in a lot of software packages. A really well-known one is one called ANSYS. And a lot of software have their own FEA built in. So in this lesson, we're not necessarily asking you to understand the math behind it all, the true math. What we're asking you to understand is, can you go set up this simulation? Can you go in and can you actually take it and correctly put the part in there? Can you correctly associate the fixed points? Well, like, let's say we're just going to take a cylinder, and the cylinder is laid this way, and we're going to pull it. We're going to put force on it that stretches it apart. Can you correctly go say, okay, I need to fix this in, I need to attach it, I need to set it as a constraint so it can't move, and I need to apply the force on this end in the right direction so that it pulls it apart. Can you do that? That's what we're going to want to know. Can you go through the process of doing that? And setting the right material. Let's say this cylinder is going to be made out of ABS plastic, or the cylinder is going to be made out of aluminum. Can you go through the steps to do this correctly? And can you tell it to, of course, run the simulation? And can you correctly interpret the results? Can you look at the results and say, okay, this is where the hot spots are, this is where the stress is going to be, this is where I don't need as much material as I have in this design, I could remove it. Can you correctly make those decisions based off what you see? Can you say, well, you know, the stress that we're getting, this hot spot is red, but it's not red enough, or actually the stress level or the PSI value is not so high that it's going to really endanger breaking of ABS. So maybe I can use a weaker material and still be fine with this project. Can you make those interpretations? Can you say, well, the stress is so high that it's actually in danger of rupture or fracture, or the stress is lower than the yield stress, so that when it gets done loading, it's going to squeeze, it's going to actually pull itself back together. It's going to work like elastic. It's going to go stretch out, but it's not so much stress that it won't go back to normal after it's done. Those are the things that we're looking for in this lesson. Again, you don't have to be an expert at this. We want you to be able to at least set it up and to take parts and correctly go through the checklist. Do I have constraints? Do I have forces applied? Do I have the material applied? And can I interpret those results correctly? That's what we're going for. Can I interpret and also make decisions? So finite element analysis is a superior way to design. It's much more cost effective to actually use it to figure out where your part needs to be improved in design before you actually make the part. It just makes sense. Remember, the whole goal here is lighter, faster, stronger, better, next generation products. And this FEA process is going to get you there. So enjoy. And feel free to take advantage of some, do-it-yourself projects. Make something in there that you have, you'd be curious to what it's going to do if you push on it this way or that way. Make sure you are checking the forces though, so that you're not applying kilonewtons when you're supposed to be applying newtons, because that'll throw your data off. Another common mistake that happens in this lesson is that people forget to go in and change the material. So what they'll do is it's supposed to be for like, a plastic, and they'll leave it set to perhaps steel or aluminum, and the results are like, ridiculously wrong. So check your materials, check your process. Alright, thanks for watching. Looking forward to see what you create, and we'll see you next time.